So today we're going to review some linear functions, something that you have learned about in Algebra 1 and Algebra 2. So a linear function comes in the form f of x equals ax plus b, which you learned as y equals mx plus b, or f of x equals mx plus b. And you guys called this, either one of these forms, slope-intercept form, because it gave you the slope and the y-intercept. If a does not equal 0, it's the slope. So if you want to write if m does not equal 0, then the domain and the range are both negative infinity to infinity, or all real numbers. Lines can be graphed by finding ordered pairs and plotting them. You only need 2 points. So that's a key thing. You only need 2 points to graph. The intercepts are always good points to have. The x and y intercept are always good points to have when you're graphing lines. Although you could use any 2 points you want. So we'll start by graphing. We have f of x equals negative 2x plus 6. This is the same thing as saying mx plus b. So my b, which stands for my y-intercept, is equal to 6. So I can go up to positive 6 and draw a dot. And then my slope, my m, equals negative 2, or negative 2 over 1. So my rise is to go down 2. So go down 1, 2. And then you run to the positive side 1. So there's your next dot. Now you have 2 dots, and you can go ahead and draw your line. Lay a ruler down in your notes. I'm going to go ahead and do this a couple more times. Go down 2 over 1, down 2 over 1. Just because I'm not the best drawer. And then I have enough points where I can draw a line. Not my best work, but close. It wants the domain and range. Since m, or a, does not equal 0, my domain and range are both negative infinity to infinity, negative infinity to infinity. So let's try 2 more examples. So this next problem says that f of x equals negative 3, which is the same thing as saying y equals negative 3. So what that really says to me is x is going to change, but y is always negative 3. It's never changing. So if I go to make a dot, let's say if I say x is 1, y is negative 3. X is 5, y is negative 3. X is negative 7, y is negative 3. Y is always negative 3. So here's my equation, here's my graph. This is a horizontal line. Since my y is always negative 3, and my x changes when I go to find my domain and range, x is changing. I move side to side. So my domain is going to be negative infinity to infinity. But my range, because I only have one y value, is going to be simply negative 3. It talks about this later in the notes, but I like to do it while there's a picture in front of me. On a horizontal line, your slope is always your rise over your run. You can see that I don't rise at all. I stay straight across, so my rise is 0. And I have a run. It could be called 1, 2. Here's 1. Here's 2. But it can be any run you want. 0 divided by anything is always 0. So horizontal lines, the slope is always 0. On the next problem, it's slightly different. This one says that x is negative 3. So that tells me that x stays the same, but my y changes. So x is negative 3 right here. X is negative 3, negative 3, negative 3. It's always negative 3. So y can move up and down all at once. but the x is always going to be negative 3. So since the x stays the same, my domain is going to be just that negative 3. But since y is changing and moving both up and down, my range is going to be negative infinity to infinity. So fun facts, this is a vertical line. On my vertical line, I still have a slope in m, a rise over a run. This thing rises lots. It has a rise, but it doesn't move side to side at all, so it has no run. And so if I take a rise or anything and divide it by 0, you can't ever divide by 0, so that's undefined. So vertical lines, slope is undefined. At some point in time in Algebra 1, I think someone probably told you this following acronym. HOI VUX. Horizontal, 0 slope, and they look like y equals vertical, have an undefined slope, and they look like x equals. And you can think this is as corny as you want, but I have my favorite little superhero. I call him Slope Man. And this is a negative slope. This is a positive slope. Straight up and down is an undefined slope. And a line that moves side to side to have a 0 slope. So there's my slope man that tells me all of my slopes. Equals 5. Sorry. Equals. The next one's slightly different. It's in what we call standard form. ax plus by equals c is standard form. So I have 4x minus 5y equals 0. It wants me to graph it. I have a couple options. Option 1, I can find my x and y intercepts. So to find an x-intercept, you let y equal 0. So if I plug a 0 in for my y, the y goes away. I get 4x minus 0 equals 0, which is just 4x equals 0. So x equals 0, which means because x is 0, my y-intercept is going to be the same thing. If I want to find a y-intercept, you let x be 0. So I'm going to get 0 minus 5y equals 0. Negative 5y equals 0. You're going to get y equals 0. So my x and y-intercept are both 0, 0. That didn't help me too much because I need 2 dots to graph a line. So you could plug in a number and solve. You could plug, for example, I don't know, let's let x equal 5. So change the screen, when x equals 5, I get 4 times 5 minus 5y equals 0. 20 minus 5y equals 0. I'm going to add the 5y over. So 20 equals 5y. So y equals 4. So I have another dot, which is 5, 4. And now you can draw your line. Something else you could have done, which is I think what you learned in Algebra 1, is that you solve for y. So 4x minus 5y equals 0. I'm going to add the 5y over. 4x equals 5y. Divide everything by 5. So 4x over 5 equals y. I'm just going to rewrite that. Y equals 4 over 5x. And then a plus 0. That 0 is my y-intercept, and that slope says go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, which is the same as I already had. So you can draw your line. I'm going to put one more dot in it by going down 1, 2, 3, 4. I went down 4, which means I need to go to the negative 5. So a negative divided by a negative is positive. 1, 2, 3, 4, 5. And then you can draw your line in like that. This is a regular line, so my domain, no x or y missing or anything. My domain is negative infinity to infinity. My range is negative infinity to infinity. So speaking of slope, I have a slope formula, which you learned a long time ago. It was on your Algebra 1 star sheet. M equals y2 minus y1 over x2 minus x1. And this triangle thing is called a delta, and it means change in. So it's the change in y over the change in the x. We talked about on the previous page that vertical lines have undefined slopes, horizontal lines have 0 slopes. Okay, so as corny as this might sound, I actually go in and label all of my points so I don't mess anything up. So x1, y1, x2, y2. And the formula is m equals y2 minus y1 over x2 minus x1. So I have negative 3 minus 8 over 2, no, not over 2, sorry, over 2 minus negative 4. You'll notice that I didn't change any signs or take care of anything yet. I literally just plugged the numbers in. So on top, negative 3 minus 8 is negative 11. And on bottom, a minus makes a plus. So 2 plus 4 is 6. That doesn't reduce. 11 is a prime number. So that is my final answer. Try the next one. x1, y1, x2, y2. So if I do my formula, I get negative 4 minus 7 over 2 minus 2, which equals negative 11 over 0. You can't divide by 0. That's called undefined. And that means that I had a vertical line. And you can tell that it was a vertical line because if you remember earlier when I was talking about the vertical line and I said that the y changes, but the x's don't change. So if you look right here, these x's didn't change. Next one, x1, y1, x2, y2. Oops, y2. Negative 3 minus negative 3 over negative 2 minus 5 gets me 0 over negative 7. You can do 0 over negative 7. 0 divided by anything is always 0. You can see here my y values didn't change. And when my y values stay the same, but the x's change, that is a horizontal line. And we also know that because the slope is 0. Okay, so now we found the slope from points. Let's find the slope from an equation. So let's copy our equation down. 4x plus 3y equals 12. And if I could get this thing in the form y equals mx plus b, I could absolutely find that m. So I'm going to get the y by itself by minusing x from both sides. 3y equals, I'm going to write the x first. So the x is a negative 4x, and that 12 is a positive, so plus 12. Divide by 3, divide everything by 3. Not one piece, everything. Y equals negative 4 over 3x. Sorry, that 3 kind of looks like an 8. And then 12 divided by 3 is plus 4. So my slope is negative 4 over 3. The next problem gives us some information and it wants me to graph it. So it says I go through the point negative 1, 5. So go over 1 and up 5 and, over 1, up 5. So there's my first dot. From any dot, here's my slope. So I like to put the negative in the top. So this means go down 5 and to the positive. So to the right, 3. They're not both negative, just one of them. Because if they were both negative, it would be a positive because a negative divided by a negative is positive. So from this dot I'm going to go down 1, 2, 3, 1, 2, 1, 1, 2, 3, 4, 5. And then I'm going to go over 1, 2, 3. So here's my next dot. I can do that again. I can go down 1, 2, 3, 4, 5, over 1, 2, 3. And then you can go in here and draw your line. So the stuff up top we talked about earlier. Again, you can draw your slope man. And now we're going to look at where. Why do we learn about slope all the time? Every year we talk about slope. Well, slope in calculus is what we call the average rate of change. And it has this formula. F of something is a fancy way of writing y. So this is like y2 minus y1 over x2 minus x1, which is our slope formula. And we use the average rate of change to see the trend in data or in real life situations. So let's look down here. It says that Google spent $2,800 million on research and development in 2009. But then in 2013, they spent $8,000 million on research and development. So what is the trend? How much are they? Obviously, this is increasing the positive slope. So what's the trend? So if I go over here, here's my x1, y1, x2, y2. So I'm going to do 8,000 minus 2,800 over 2013 minus 2009. On the top, you're going to get 5,200 over 4. And please don't write that as your final answer. You can reduce that. It comes out to 1,300 billion per year. It's an increase of, on average, 1,300 billion per year that gets spent on research and development. Another super common place that linear functions are used is in economics. And we talk about cost and revenue and profit. So a cost is what does it, what does it, the item, cost to produce, to make? There's labor charges and materials charges. So what do I have to pay to make these items occur or be made? Revenue is what you bring in. It's your money. It's your money that you bring in. Sorry, my pen's acting funny. So if you sold 10 units for $20 each, you would bring in $200. Revenue is the amount of money you bring in. Your profit is the difference in the two. So your profit is what did you actually make. And to find out what you made, you take your revenue, the money you brought in, and you subtract away what you had to pay to make those items occur or be produced, and that will be your profit. So let's do an example that involves these. So assume the cost to produce an item is a linear function and all items produced are sold. So there's no back storage of items or anything like that. The fixed costs of 1,500. The variable cost is 100. So for my cost, C of X equals, it costs me 100 per item, plus I have a fixed cost, probably the materials, or the labor, or what it costs to rent the space to make it, any of the above. So there's my cost function. My revenue function, my R of X, it says that they sell each other for $125. So 125 X for each item. And if I want to find my profit, I do my revenue, the money I brought in, minus the cost, what it cost me to make it. So if I do that, I'm going to get 125x minus parentheses. Don't forget the parentheses because you're going to distribute the negative in right here. This negative is going to get distributed in. So that's equal to 125x minus 100x. Oops, this was a plus. And then minus 1500 because I distributed the negative in. So my profit model is 25x minus 1500. So then the question says, how many items will need to be sold for there to be a profit? For there to be a profit, P of x must be greater than 0. So that means I need 25x minus 1500 to be greater than 0. Going to add the 1500 over. And I'm going to divide by 25. And x has to be greater than 60 units or items. So as long as I make more than 60 units or items, I will make a profit.